This video is all about angles. We have a few learning objectives. We want to be able to convert easily between degrees and radians. We want to determine coterminal angles for a given angle. We want to determine a reference angle for a given angle. And then we're going to use formulas for arc length and sector area to compute those values, or if we're given those values, be able to compute the radius. So, a lot in this section. So, first thing, what is an angle? You start out with just a ray, which a ray has an end point and an arrow. So the end point here, an E, and then the other side extends forever. We usually pick another point that lives along the ray so that we can name it. And we name it EF because the end point comes first, and then the point that lives along the ray comes second. Now, the first point, let's see, the angle is the union of two rays. So an angle, we take ray EF, and then we add to it ray ED. So here's D, and this should be F, not another E. And this is angle DEF. So the vertex is the shared or common endpoint of the two rays. One of our first goals will be to measure angles, and in order to do that we need to have an initial side and a terminal side. So to measure, you have to have a starting point and an ending point. And I like to put them on the XY plane, which is called standard position. We put the initial side on the positive x-axis. And then we measure counterclockwise to the terminal side, which could be here. It could be all the way over here. But we start there on the positive x-axis. You notice when I drew my picture, I went counterclockwise. That's a positive angle measure. Positive angle measure is counterclockwise. Counterclockwise. And if you go clockwise or down into the negative quadrant 4 from your positive x-axis, that's a negative angle measure. So that helps me to remember it. If I move from the positive x-axis in the positive direction into quadrant 1, it's a positive angle measure. If I move down into quadrant 4 where the x values are negative, it's a negative angle measure. We measure angles in two ways. We use degrees, and there are 360 degrees in a circle. So 1 degree is 1/360th of the rotation around a circle. That's pretty easy to remember. You always think about making a 360-degree turn as turning all the way around. A radian is a little harder to explain. The radian is the measure of a circle such that the radius, the length of the radius, is equal to the measure of the central angle of a circle that intercepts an arc length that's equal to the radius. So the radius and the arc length are the same. So radius and arc length would be exactly the same. It's not important to remember that. What's important for you to remember is that there are 2 pi radians equals 1 circle. So 2 pi radians equals a circle. 360 degrees is a circle. So 2 pi radians is 360 degrees. So that means that 1 radian is equal to 360 over 2 pi, or 180 over pi degrees, or 1 degree is equal to 2 pi over 360, or just pi over 180 radians. So you can convert back and forth. Let's look at an example. We want to convert 120 degrees to radians. 120 degrees is equal to, well, this is degrees, so I need to have something with radians in it. I want to end up with radians, so I take 120 degrees times pi radians over 180 degrees. That way, pi, I have degrees over degrees, which would cancel. That's kind of how I remember it. Pi and 180 is the same distance around a circle. So pi radians over 180 degrees is equal to 1, because they both represent half the way around a circle. If I have degrees on top, I need degrees on bottom. So 120 over 180, well, that's the same thing as 12 pi over 18. But we can do better than that because 6 goes into both of those things. So 2 pi over 3. If we want to go from 4 pi over 3 radians, then we do 4 pi over 3 radians. Now we want the radians on the bottom, so we put the pi on the bottom, and we have 180 degrees on the top. Anytime you go from radians, if you start with a pi, the pi will disappear as you convert it to degrees, so you end up with 4 times 180 over 3. But again, we can do better than that. 3 goes into 180 60 times, so 4 times 60 is 240 degrees. Now, I know you could use your calculator, but on test 1, you won't be allowed to use your calculator, so I'm trying to show you some little tricks for simplifying things. Now, practice these on your own. Pause the video, write them down, do them all by yourself, then start the video back up, and we'll go through them and compare answers. Let's go through and compare. So the first one was 15 degrees. So I put pi on top, 180 on the bottom, and multiplied. And then I went through the simplification, just to show how my mind went through it. First thing I saw was that 5 would go into those things. I knew 5 went into 180 because it ends in 0, and if 10 goes into it, then 5 has to go into it. Then I simplified that as much as I could. Dismiss that. I have 126 degrees, and I got kind of lazy about putting the units in there until the very end. So 126 degrees. I multiplied, I simplified this. First, I just divided by 2, and then I saw that both of those were divisible by 9. This one was negative, so we keep the negative sign. Easy enough to know that you could cancel the zeros away, and then I had something that 3 goes into 15 and 3 goes into 18. So those were not too bad. This one, I have pi over 6 and 180 degrees over pi, because now I'm going from radians to degrees. My pi's cancel, and I end up with 30 degrees. You'll have those memorized by the end of the semester, that 30 degrees is pi over 6 radians because it lives on the unit circle. 3 radians, now this one, there's no pi to cancel. It's just a whole number of radians. So this would be an exact answer, 540 over pi. I did go ahead and plug it into my calculator to get an estimate. And then F, we have negative 3 pi over 4. Again, I kept the negative sign. The pi's canceled. Since I had just multiplied 3 times 180 up here, I went ahead and did 3 times 180 and just put 4 into it. And 4 goes into 540, negative 135 degrees. So if that didn't go smoothly, go back and practice some more. Coterminal angles are angles that have the same terminal side. An angle of 140 degrees and an angle of negative 220 degrees are coterminal angles. That's the thing about angles. There are lots of different ways to get there. So coterminal angles. In standard position, they have the same terminal side. They end at the same place. Example 2 asks us to determine 2 angles, one positive and one negative, that are coterminal with a 315 degree angle. So I'm going to just kind of estimate where 315 degrees would be. Well, I know this is 90 degrees. This is 180 degrees. I go another 45 degrees. So that would be 225. So 315 is over here somewhere. So one way I could get there would be to use a negative angle. So I do 360 minus 315, so that would be 45. So this one is a negative 45 degree angle, ends at the exact same place as a 315 degree angle. The other coterminal angle is the one that loops around and then comes all the way back. That's how you get a positive one. So you have 315 plus 360, which would be a 675 degree angle. And oops, let's do, well, I have it here, minus 45 degrees and 675. So here we go. And that's the way I put the solution. I did 315 minus 360. So you imagine starting here and then moving back this way, which brings us to the negative 45. Determine two angles, one positive and one negative, that are coterminal with a 2 pi thirds radian angle. So let's estimate where that should be on a circle. Well, 2 pi in an entire circle, so 0 pi over 2 pi and 3 pi over 2. So 2 pi thirds would be over here somewhere. Let's do it exactly the way I did up here with degrees. If I start with 2 pi over 3 right over here, and I move in the negative direction 360 degrees, I end up back where I started, because 360 degrees, or 2 pi, is an entire circle. So pi over 3 minus 2 pi. Well, not going to get to use the calculator on that first test, so I better practice my arithmetic. I need a common denominator of 3, so that would be minus 6 pi over 3. Gives me 2 minus 6 is minus 4 pi over 3. And then the other one would be to do 2 pi over 3 plus, I'm going to go ahead and give it the common denominator, save myself a little writing, 8 pi over 3. And there's the pretty solution. Your turn. You get to practice. So we want to find the angle between 0 and 360 degrees that is coterminal with the given angle. So we want to take those negative ones and make them positive. We want to take those positive ones and bring them down so that they're between 0 and 360. And the same with the ones that are in radians. We want to take the negative ones, make them positive, take the positive ones, and subtract intervals of 2 pi until we end up back on the unit circle between 0 and 2 pi. So I know you paused the tape and you did all these on your own. First one was easy. Negative 40 plus 360 is 320. Negative 110 plus 360 is 250. 700 was too big, so we subtracted 360 from it and got 340. 1400 was too big, so we subtracted 360 from it. Still too big. We subtracted 360 from that. Still too big. Subtracted 360 from that. Finally an answer. Now you could have looked at 1400, and then if your calculator is active, you could have, let's clear out this old stuff, said 360 times 2, 720. Nope, that's still not going to be big enough. So 360 times 3, still smaller than 1400. 360 times 4, that's 1440. So if I subtract that from 1400, then it's going to be negative. So I would do the 180, and I could do 1400 minus the 1080 and get the 320. So you could multiply until it gets bigger than 1400, then you know you've gone too far. Or you could be really savvy and have just noticed that, oh, that's where I need to stop, is at 1040. So let's go on to the radian measure ones. We have pi over 6, and I went ahead and wrote everything with its common denominator, because you got to do it anyway. So 2 pi, you just double your denominator. So we have 12 pi over 6 is 2 pi. Gives me 11 pi over 6. This one I had to subtract. The denominator was 3, so 6 pi over 3 is 2 pi. Subtract and I'm done. Again, I have 12 pi over 6. I subtract and I'm done. This time I had 9 in the denominator, so I subtracted 18. Still too big. I did it again, and then I got my answer. Now this next practice is a little different, so let's do that one together. We'll do A together, then we'll pause and you can do B on your own. We want to determine if the following angles are coterminal. So that's just fancy math language, is can you get to one from the other in a complete circle? So if we start with 320 degrees and we want to know if we can get to negative 50. So let's subtract 1 trip around the circle from 320 degrees. That takes me to negative 40 degrees, so no, these are not coterminal. You could have gone the other way. You could have said, oh, from negative 50 degrees, if I add 360 to it, I end up at 310 degrees. So again, not coterminal. You can't get there from here. So try part B and see if those are coterminal. Okay, these two were coterminal. I started out just subtracting because the first one was positive. You could have started with negative 23 and added to see if you could get to pi over 6. But again, I got my common denominator, subtracted again, and yay, I ended up there. Let's talk about arc length. This is something you're going to want to write this formula down on a flashcard or make yourself a Quizlet, because you're going to need to memorize these things. Arc length is just the length of the portion of a circle. And in a circle of radius r, so you know the radius is the distance from the center to the outside, S subtended by an angle with measure theta. S is equal to the radius times the angle measure, and it has to be in radians. S is equal to R times theta. R equals radius. Theta is your angle measure in radians. Radians, not radiuses. Okay. Determine theta if the radius of a circle is 16 feet and the arc length subtended by theta is 10 feet. So we have our formula, we just have to use it. We know what S is. S is 16 feet. Let's see. No, the radius is 16. The arc length is 10 feet. So 10 is equal to 16 times theta. So theta is equal to 10 over 16 is equal to theta. And looks like 2 is as good as it gets. So we have 5 over 8 is equal to theta. B, we want to determine the arc length subtended by a 45-degree angle of a circle, and the radius is 12 feet. Okay, so we need to write theta with radians, and it's actually in degrees, so I'm going to multiply this by pi radians over 180 degrees. So 45 over 180 is 1/4. This is pi fourths. 45 degrees is pi over 4. Again, by the end of the semester, you're going to know this so well. So our S is equal to R, which is 12, times pi over 4, and then 12. 4 goes into 12, 3 pi. So my units here are radians. My units here are feet. And again, I don't have a measuring tape with pi on it, so if I actually wanted an estimate, I would probably plug that in the calculator, put in 3 pi, and your calculator says 3 pi, and you say, well, duh, and then you push the little button there, and it gives you the decimal approximation, and the little button there is the one with the little arrows that lives right above enter. And there's the pretty pictures, the pretty answers. And here's some practice problems for you. So, pause, work these, then we'll compare. First one was pretty straightforward. You just needed to find the length of the arc length, with radius 12 inches, and the angle was 3 pi over 4, multiply, and I did get the estimate, the decimal approximation. So the next one was another one that was fairly simple. You just needed to convert from degrees to radians. So I did that first, 50 degrees times pi over 180. I always think about when you're going from degrees to radians, you're introducing a pi into the equation, a pi on top into the equation. So then we just plugged the 5 pi over 18 into the S equals R theta and got an answer. Part C, we had a 9-foot arc, subtends a central angle of 22 degrees, and we wanted to find R. So first thing I needed to do was get my theta in terms of radians. So theta was 22. Again, introduce my pi into the party, and I got 11 over 90, and then I just solved. So 9 was equal to 11 over 90 times R, so R was equal to 9 divided by 11 pi over 90, and 9 divided by 11 pi over 90 is the same thing as 9 times 90 over 11 pi. So I just multiplied and simplified. Had to do some fraction arithmetic there. Part D, we have a 20-meter arc of a circle with radius 7 meters, subtends a central angle theta. Determine the measure of theta in radians and degrees. So when you just start with your formula, S equals R theta, your theta is automatically in radians. Don't need to do anything to it. But then you have to take it from radians to degrees. Usually that pi would cancel, but this radian measure doesn't have a pi in it, like radian measures often do. So you end up with a pi in the denominator here. And then we get 163.7 degrees. Okay, we have area left. The area of a sector, so again, this will be something that you'll want to make a flashcard with this formula. Area of a sector is 1/2 theta r squared. memorize it. So determine the area of a sector if the radius of the circle is 16 feet and theta is 60 degrees. So again, R equals radius, theta measured in radians. So we're going to determine the area of a sector. This is example 5. Area is equal to 1/2. Theta, oh no, my theta is in degrees. So theta is equal to 60 degrees times pi over 180 degrees. The degrees cancel with degrees, and I have pi over 3. So this is pi over 3 times the radius squared, and the radius is 16 feet. And so I'm going to come down here. 1/2 pi over 6, 2 times 3, 16 squared. Don't know that off the top of my head. 256. Divided by 6, is it something pretty? No, it's not. So it's 128 over 3 times pi, which is approximately equal to 134.04. Now what are my units? This is area, so it's going to be square feet. And the way you can remember that is this radius is 16 feet. You have 16 feet squared, so your answer is going to have feet squared. So, use the given information to find the area of the sector. Okay, this is your practice problem. So you've got 3 of them. Give them a try. We'll meet back and compare answers. Okay, so even the first one wasn't completely straightforward because it gave you the angle degree in degrees instead of radians. So you had to convert it to pi over 4 and then multiply 1/2 theta r squared. And I went ahead and squared it in my head there. 6 squared is 36. Part B, threw a little monkey wrench. It gave you the diameter instead of the radius. So radius is just half of diameter. So you could have done that in your head easily enough. That's 5. And then 5 squared is 25. And you have 2 times 2 is 4. And again, I got a decimal approximation and I put in my units. The last one has an automatic sprinkler, sprays a distance of 20 feet. So that's the radius. That's how far it's spraying. What is the area of the sector it waters? And it's rotating 30 degrees. So again, I converted to radians. And then I did the arithmetic. 1/2 theta r squared. Looks like, ooh, this is our last thing. We're going to do an application. We'll do this one together. In central pivot irrigation, a large irrigation pipe on wheels rotates around a center point. So, application problems, if I can draw a picture, I like to do that. So I have this irrigation pipe that goes around in circles. And let's see, a farmer has a central pivot system with a radius of 400 meters. So this is 400 meters. Water restrictions only allow her to water 150,000 square meters per day. What angle should she set the system to cover? Write the answer in radian measure to 2 decimal places. So, you will learn I'm not that great an artist, but it still helps me to visualize what's going on, even though my pictures aren't that great. So there's my measure theta. Now, we want the area to be equal to 150,000. But I know a formula for area. Area has to be equal to 1/2 theta r squared. I know what r squared is, so I'm going to set 150,000 equal to 1/2 of theta times 400 squared. 400 squared is 16 with 4 zeros, so 160,000. Well, I have 160,000 times 1/2, so let's simplify a bit. Divide that by 2, it's 80,000 theta, so 150,000 divided by 80,000 is equal to theta. So let's see, 150, I'm just going to do 150 divided by 80. That'll be the same thing. And I get 1.75. 1.875. And it asked me to round it to 2 decimal places. Okay, be annoying. 1.88 radians is equal to theta. So, if WebAssign asks you for 2 decimal places, then you darned well better give it 2 decimal places. Alrighty, you've learned all about angles. We actually learned a whole lot. We learned about converting back and forth. So let's think about what you're going to make flashcards of. You want to have your formulas for conversions on a flashcard. You want to have your formula for arc length and your formula for sector area on a flashcard. So I'll just make us a little note down here. Make flashcards for conversions. So pi over 180 times degrees equals radians, and 180 over pi times radians equals degrees. Area is 1/2 theta r squared, and the sector is just equal to theta times the radius. So make yourself some flashcards or whatever method you like to use. You can do this.